Begin. So let's take a look at something called an array, and actually go ahead and comment that out a moment. All right, so let's take a look at this thing called an array. Now you're familiar, of course, with integers and all that. So if let's say I had a group of integers I wanted to make, I1 equals 123, and I2 equals 4, and you can see kind of if I wanted to have a bunch of them, you can see the pattern there. Hopefully, if I've taught you anything, you see the pattern of making multiple integers, declaring and initializing multiple integers so that you can use them. Now, there's actually a much better way of doing this. It's called an array, A-R-R-A-Y. And a lot of my students, you guys come from computer science principles, where all we did was Python and a little bit of JavaScript, but mostly Python. And you probably remember the list, and it's a little like the list, except there are a few differences, and let's go into them. Now, firstly, an array is basically a group of one kind of variable type. So already you see a difference between this and the Python list. Additionally, the thing about an array is that when you declare and initialize it, you're not really initializing it. You're more doing what's called allocating. You're not giving it actual values, although when we make a new list, all the elements in the list do get set equal to 0 or empty strings, depending on the variable type. But in this case, you're not really setting its values. You're just setting how many are going to be in there. When you make an array, which is like a list of one data type, you have to decide how big it's going to be at the beginning and then never change that number. An array does not grow or shrink. But this is how it works. You declare it right here on this left side by saying it's an integer array, using these square brackets to specify that. Then you have the name of your array. And then for initializing / allocating, you do equals new data type again with the brackets, but this time you put a number in between the brackets, and that number determines how large our array will be, which you can see down here where I initialize each what are called elements of the array, initializing the elements of the array. And it's where I go through each of the 6 elements, in this case 6 because I allocated it with 6 integers, initialize all 6 elements of the array. Now, something to understand about that in memory is that you know that when we make, for instance, an integer, it goes into RAM, takes up 32 bits of space, and fills them in with zeros and ones. So pretend that's a bunch of zeros and ones equaling 32. Now, when you make an integer array, when you say equals new int, and give it a 6 or something, or let's do a smaller value. Let's say 3. That's a 3 right there. So let's say I make it for 3. What that means is immediately we make. Actually, I should do it like this. We make this thing of 32 zeros in here. So pretend this is 32 zeros. And you make 3 of them right next to each other in memory. So that way, an array is just this continuing kind of variable that just takes up that much space in memory. In this case, it takes up 32 times 3. In other words, it takes up 96 bits in memory. So that's kind of why you have to declare it and allocate it immediately before doing anything else, because you need to actually set up the space for it. Now I'm going to go ahead and change my array so that way it's just 3 elements. And you'll notice that when I do that, 1, I go 0, 1, and 2. Just like with string indices, array indices start at 0 and end at the length -1. And the second thing to notice is each of these have the same name. I don't have to do I1 equals 123, I2 equals 4, or anything like that. It's just each element in the array. So the nice thing about that, and we'll come back to this initializer address later and that part, is that now when you're printing them out, you can't really use a for loop to print out, you know, all three of them if it was like, you know, system.print whatever, you know, I1 or 2, you know, you're not able to do that. But with this, you are able to access each element in the array because this thing here goes 0 through the length. This is how you access the length of the array. I could put 3 here, or I could just put array.length. And then access each element in the array, which I'll show you in just a moment. Right here. The second line here, the second green line down here at the bottom. Because it's, you know, it's the element, 2 spaces, and then the next element, and then 2 spaces, and the next element, then 2 spaces. So real quick, you can see how we waited till after for loops and while loops in order to do this. It's actually pretty nice. Now, if you just try to print out an array on its own, yeah, that worked in Python. It doesn't work here. You see this weird thing here? All that means is that that is the actual address in memory that all this stuff is located at. So if I was looking at RAM, that would actually be the address I would use to access this 3-integer space. And when I start changing things about it, it would go ahead and just kind of write directly over it. Let's see, 123, and pretend it's in binary. 4 and 12. And again, just pretend those 3 are in binary already. So there is also another way that you can do this, and it's pretty nice, is that you can do what's called an initializer list. Again, we'll might as well do that one now. Let's say I had an initializer list with the same number of values, same all that stuff, and instead of doing this or any of these things, I decided to do the whole thing in one line. And that's actually possible. As you can see right here, I declare it still as integer array with the variable name arr, then do equals, and then I use these curly brackets like you might use in a for loop or a method, and I just put the 3 elements in there. And with that, it's able to automatically know how big the array is. Obviously, it's 3 elements because it got 3 elements, and it initializes each of those elements to those values. It's called an initializer list. And you can see it does, you know, the same stuff that we expected. Different address in memory because it's going to be a different address every time we make a new variable. And, you know, on each run, it's probably going to be a completely different address there. And I guess I should say in advance, because someone might mention it in the comments, this is technically not the address, but it's basically the address. We're not going to go too deep into what this actually is, but it's sort of technically the address of the array. Now that's important to notice, is that this is basically the address of the array. So watch this. Let's look at our swap method down here. Now the swap method, you'll notice, does not return anything, but instead makes a new integer, which holds one of the spots in the array, and then swaps the 2 variables. Now, if I did that up here, watch, before I print it out and after I print it out, I'm going to add in some statements like system.println after swapping. I just want to show you how this works. And let's go ahead and do that. So I swap ARR, and I want to swap index 0 and index 3. Index 2, sorry. Because that would be swapping that number and that number. So okay. So I swap them, and you'll notice it swaps just fine. And a lot of you are probably fine with that, but some of you are noticing, wait a minute, why did that work? After all, I didn't do ARR equals that. You know, like if you had an integer or or a double, and you said to increment it in some other method, unless you return it, it doesn't work, right? But that's the thing. Arrays don't need to. You notice how when I print it out, it prints out the address, quote unquote. Well, that's the thing. Arrays are passed by reference, meaning by address. As in, when this thing makes changes to it, it literally makes changes to it. It's not just given the values, like how an integer is passed by value. It's passed by reference, meaning it literally goes to that exact same space in memory and swaps those numbers around. Which is important, because that means that whenever we hand an array to a method, it will change it without returning. So that is basically passing by reference, and feel free to ask questions in class or in the comments below. Alright, so let's just take a moment, reflect on what we did. We declared and allocated an array, initialized the elements, and then we got rid of all that and instead used an initializer list to make our array. Then we printed out the address. Then we printed out all the elements in the array using this for loop, which goes through 0, through array.length, or arr.length, because that's the name of our array variable. And then we did a swap where we passed our array by reference to a method that would swap the values, and then printed out them again, showing that they were actually swapped. Alright, so let's do one last thing before we wrap up, which is duplicate our current array. Now, when we duplicate, we're making a second one, making a copy. So first, we got to go ahead and make a new array that is the same length as the old one. So our new array needs to be made as a new array that is of the same length. Now, the reason why I'm doing that like this, let's say I left this as a constant number instead of using the array.length. And we could say the same thing for this for loop. But let's say I just have this as a constant number. Well, let's say at one point I decide that I want to change the number of elements here. If I did that, now it would actually crash the program, because I'm trying to duplicate it by going through each element in the arrays, but this isn't big enough. I'd have to go in here and make that 4, and then it would work just fine. But rather than having to change it every time I alter this one, I'd rather make it automatically change. I know it needs to be the same length as array, so I'm going to use array as the same length as arr. So I'm going to go ahead and allocate it with that much space anyway. The program will know how big the array is and just handle that problem, so I don't have to think about it in advance. So yeah, I make the space for it, and then I just kind of run through the length. And this could be new arr.length, it could be arr.length, it could actually be that static number, but again, we went through why that wasn't a good idea. So as long as this goes from 0 to the end of both arrays, setting each element in the new array equal to the element in the old array at the same values, then with that, these are now the same. And I'll go ahead and tab this forward so that way we can have it looking more organized. It'd be easier to see. So yeah, there you go. So notice I duplicated the array after swapping some values. Swapped some values, printed them out, duplicated my array, printed both of those out. And I'm using this method down here, print array, that I wrote. That does the same exact thing. I'm just printing out all of the values. Notice it's the same stuff. I just added in a print line at the end. Those of you from computer science principles remember that this is called parameterization right up here, and abstraction, you could also say. The parameterization, because it's not going to print out the same array every time. It's just going to print whatever array I pass to it. So that allows me to cut down on lines of code, cut down on the amount of work that I have to do. There's no point in reinventing the same wheel every time, because you can just build it once. Okay, So that basically is how we use and make arrays. You should have from that how to run through an array, how to declare, initialize. Actually, let me start from the beginning. You should be able to declare, allocate, initialize an array, traverse an array, understand that arrays are passed by reference and how you can take advantage of that. No need to return, and so on and so forth. Oh yeah, and then after taking advantage of that, you should be able to understand how to duplicate an array, and just remember how to print out an array. All right, and you're good to go. That's it. Thanks for watching.